Solve this spring mass system problem. We have a mass of 0.5 kilograms suspended from a spring, and we need to analyze the forces and motion when it's pulled down 60 millimeters. Let's start by drawing the system in its equilibrium position. Here we have the spring hanging from the ceiling with the mass attached at the bottom. In this position, the spring force exactly balances the weight of the mass. Now, when we pull the mass down 60 millimeters, the spring stretches, and its tension increases to 7.0 newtons. The student needs to apply an upward force to hold it in this position. To find the force applied by the student's hand, we need to consider all vertical forces. The upward forces are the tension and the hand force, while the downward force is the weight. These must balance when the mass is held still. So, the hand force plus 7.0 newtons equals 4.905 newtons. Solving this, we get that the hand force must be 2.095 newtons upward. Now, when the student releases the mass, it will perform simple harmonic motion. The restoring force follows Hooke's law, which states that the force is proportional to displacement, but in the opposite direction. We can find the spring constant K by using the tension when stretched. K equals 7 newtons divided by 0.06 meters, which gives us 116.7 newtons per meter. To find the initial acceleration when released, we use Newton's second law. The net force equals mass times acceleration. The net force is the spring force minus the weight, giving us an initial acceleration of 4.19 meters per second squared upward. Finally, the initial amplitude of the oscillations will be 60 millimeters, which is the initial displacement from equilibrium